So the next lab, this morning's lab is going to be on unit testing. So far you guys have kind of learned the basics of developing Rosetta protocols and how to manage that development through Git. And then we've gone over some C++ basics and some object-oriented programming basics. So now we're going to talk about kind of how do you know, like you've written some code, how do you know that it's working? So in this lab, we're going to talk about unit tests and also how to write those. And for the part that you'll be doing, you'll practice writing unit tests for code that already exists. So why are tests important? So we have some things written on here, but what do people think about tests? Why is that important to test your code?
We need to check if you have introduced artifacts. You know, maybe because of the kind of system that you're trying to model, or you've introduced unnecessary artifacts, or it's not generalizable or something like that, and you want to test it out. So you built it on something which is like kind of a toy for you, and then you're testing it out, something which is
Right, so I'm just going to say it back so people can hear. So to make sure you haven't introduced any artifacts, so maybe you had kind of a particular system in mind that you were running your code on, but to see if it's generalizable for other systems. Anything else? Does anyone work on any group projects where there's multiple people developing code on the same project? Yeah, are you ever worried about when they change something in your code or they add new code? So that's a big part for an important part of testing. So it can let you, kind of like we said at the beginning, it can let you know that your code is working, whether that be on multiple systems or different edge cases. But it also lets you know if your code has been broken. So whether that be by you a few months later and you're working on some code that you haven't touched, or someone else is merging changes into your code, or you're merging changes into someone else's code. So that can help ensure that you could be touching something that you think has no other effect, but there could be something related that you didn't realize. So tests are really important for that. It also helps shield against any bugs or edge cases. So these are really important to make sure your code is actually working and can be maintained later on. So hopefully we're not all writing code to just use that day and then never using it again. That's not a super efficient way to live your life. So if you have tests written, then you can make sure months later, maybe some versions have changed, but you can run your tests to make sure, the better your tests are, the more confidence you'll have in your code later on, as long as those are working. So there's different levels to testing. So what we're talking about today are unit tests. So that's going to test kind of like, it sounds like a unit of code. So that could be testing like a single function that you implement, or maybe you have tests that are testing a class that you have written. Then integration tests are more testing things working, like are different aspects of your code working together like they should, or testing maybe a whole application. But integration tests are really testing like, is this code working the way it should? It's not a scientific test to know like if you were testing a folding application, for example, is it running? Is it working? It's not testing if the end structure is actually like the most optimized, lowest energy folded structure, if that makes sense. And then you have scientific tests, and that's more what a scientific test is for. So that's going to be testing on a larger data set instead of testing on maybe a couple of use cases. So real quick on this, your unit test should be pretty really fast. It's testing one function, so a single unit test should run really quickly. An integration test might take a little bit longer, but it should also be fast. You don't want your integration test taking a long time either. And then the scientific test, those are not going to be ran as often. So, they're going to have to take longer if you're testing the accuracy of something. So here's a few scenarios that could be possible while you're developing your code. So maybe your code doesn't compile. So that means your code is unusable, and it's up to the developer to fix it, right? So this is not a good scenario, but it's it's addressable. It's not compiling, so you need to fix whatever's causing it not to compile. Maybe your code compiles, but it doesn't run, or maybe you're writing in Python and your code just doesn't run. So still not good. The code is unusable. It's up to you to fix it. Maybe your code runs. Yes, and you're like, done. But maybe it's running and it gives some error message when there's specific scenarios or specific inputs that are used. And this is really like kind of the best case scenario, that like it runs when you're expecting it to run, and if there's a incorrect input or something, it gives an error message and lets you know that that's not working. Versus the last thing, which is the code runs, it doesn't give any error message, but it's actually giving you the wrong output. And this is the worst case scenario. So that's one thing that we want to try to address with our test, is to find those scenarios that maybe you didn't write your program thinking about, but then you're like, oh, how could someone else be using this? Or how could there be some edge case that I haven't maybe thought about, where it would run, but it would run incorrectly. And then you as a user, when you're actually using that for your project, you're not going to be thinking about that, and you're trusting that. And then who knows, how far up your pipeline that is, and that error is going to propagate throughout. So this is just kind of like, this would be, this would, when your code is like not compiling, these are like integration tests are gonna catch that. These specific scenarios, hopefully you're gonna catch with unit tests, and then that's gonna be easy to track down because you're like, oh, it's this function here that's failing. And these are more system tests, or like the scientific testing that we talked about. So has anyone heard of test-driven development? Rachel? Has? She's the only person I saw. Yes, Bill? Okay, we have a few. So test-driven development is the idea that when you are developing code, that you actually write your test first, and then you develop your code so that the tests pass. So the benefit of this is that once you already have those tests, then you can kind of work on optimizing and changing your code, and you have a really easy way to make sure that you didn't mess up some other functionality. So maybe you wrote something and you go back and look at your function, you're like, I think I can make this more efficient, and you change it a little bit. But if you didn't have a test, you would have, like, how do you know that you didn't mess up the functionality that you had before? So that's one good way to use test-driven development, or a benefit of that. So like I said, you're gonna write the test. So in this case, we would say, like, we're gonna have some function that always returns 4. That's just the idea. We don't have the code written for that. We write a test to make sure that does, and then we implement the function and then make sure the test passes. So if your prompt for test-driven development, if your prompt was write a program that can compute the square root and return a real number, so you would you could have your signature, and then you would think about the different edge cases. So you wouldn't want to test just one number, but test different scenarios that could happen to make sure that the output you expect, that you're getting the output you expect. So you would write your test and then implement your function for that. So unit tests, like I said, are small automated tests that really are checking one function. So this should, if you are writing with object-oriented programming, this should be fairly easy because you are writing already in those units. If you're already writing your code in those units, and so you can test those. So how are unit tests helpful in this? Like, why not just run integration tests? Like, if you have a small example that you can run your whole program on, why not just run an integration test and not worry about writing unit tests for all of your code? Any ideas? What would be the benefit of having a unit test to find a bug versus having a integration test, even if that integration test is fast? Exactly. So you would be able to know where that bug is coming from in your code. So if you had 30,000 lines of code, you could search through all of that code to try to find what's causing your integration test to fail. Or with a unit test, you would know exactly which area you need to look in. So for Rosetta, we have actually kind of a test suite. So there's already going to be a format of how to set your unit test up. I think this is really great. So there's been a lot of people in the community that have worked really hard on getting this infrastructure in place to where we have these and where they're running on the Rosetta code base continually. So essentially you're going to have, you're going to derive a class. So this is for if you're programming in C++ Rosetta. We'll talk about unit tests, how to write unit tests for PyRosetta in a moment. So you're going to derive a class from the CXS test. So you'll store those in like your test name .cxstest.hh. And then you'll need to add that file like you did in the other labs too, to a settings file so it knows to compile that. So where to put them? This is out of date, and I didn't realize because I always type main anyways. So ignore main, so my fingers will type them. So in your Rosetta path, so if you have source src, wherever you put code, so in your file system you have kind of like a mirror image of that in the test file. So your unit tests are going to go in like path to Rosetta, source, test, and then you're going to put them where the code that you're testing is. Does that make sense? Very clear where to put your unit test? So you're going to have, like I said, a class that derives from CXS test suite. You'll have a setup method, teardown, and then you'll put your test in there. So you'll use different asserts to make sure that your tests are behaving, or your functions are behaving the way that you're expecting them to.
You need to name the test underscore, for it to know that it's a test.
Yeah. So the test that you're writing, the functions that you're writing to test, just to repeat that, you'll have should be named test underscore and then whatever name would make sense there. So something informative. Yeah. So they shouldn't return anything and then just test. So how do we run those? So you will need to compile your unit test. So you'll compile that with scons. And you'll have cat equals test. So that's the main thing for compiling that. And then running those. Here's your command for running those. So you can also so that will run all the tests. You can also run one test in particular, or one class, by including your class's name on the command line for that. And I mean, I would, depending on where you're changing code, like most of the time you can test, like for what you're going to be doing today, you can test because you're not changing everything, but you will want to run unit tests for the other functions, especially if things depend on the code that you're changing. And then these are just informations for like if you have a different compiler, how to make that work. Yes. All right, so code coverage. So we would really like for every line of code to be covered by a test. This is not true. This is a really big code base, and a hard rule to enforce. But even if you're even if you have 100% coverage, like let's say you have 100% coverage, you run a tool that determines your code coverage, and it says like 100% of your code is covered. Was like, does that mean your code is working perfectly? No. So just because you're testing your code and you have certain cases that you're testing, there could be other edge cases that you haven't thought of. So I wouldn't run that and be like, oh, or if you're looking at someone else's code and you're like, oh, they have 100% coverage, like we're good to go. There could always be scenarios that haven't been caught by those tests. So making sure like the quality of those tests are also good. So how are we going to do this for PyRosetta? So the PyRosetta scripts repository is linked into the same testing server for the Rosetta test as well. And it uses the standard PyTest framework. So has anyone used PyTest before? A couple people? So we're going to use that for running our Python test. That's what I've been working with for some of the machine learning models that are written in Python, is using PyTest, and it's pretty popular in the community. So essentially for running PyTest, you just need your test to live in scripts that have a file name test underscore. So then PyTest will find those and run any functions that also start with the word test. You can also have classes that start with the word test, and it will run the methods in that class. So for the PyRosetta scripts module, or the PyRosetta scripts repository, these can actually, there's a lot of flexibility there. So these can either live, like they can live anywhere. So there's a testing directory, and you can put your test in that directory if you choose, or you can put them in your own directory, like the directory you created yesterday in pilot apps, I think is, yeah, and then your name. So it will, the testing server will pick any of those up and run those. It might be easiest to keep them for now in your directory, but I don't think we have any conventions set on that so far. So what is this going to look like for PyTest? So if we had some function defined, then we could write a test for that. So it's all based on these assert functions. So we have test underscore is the name of our function. Well, test underscore answer, but it needs to start with test. And then it's saying, okay, if we put input 3 into this function, it should return 5. Now, if we ran PyTest on the command line, so we're going to run PyTest, it picks up that there was a failure, and then it will give us some more information about that. So where is that failure happening and why is it happening? And it will tell you kind of at the bottom a little summary of like how many tests failed, how many tests passed, and how long that took. So PyTest, like I said, it just uses simple assert and asserts, and then you just run that on the command line. You can install it with pip. Yes, and you can also use asserts that make sure there's a certain exception raised. So if there's a case in your code where when you get to a certain point, if some condition is met, you want it to exit and have a certain message, then you can make sure you can test that that's working. So if you are digging into this and you want to find more information on PyTest, they have, I think, really good documentation. So I included the link in these slides, and I think there's also a link included in the Python lab. All right, so what do we need to test? So we have anytime you have maybe some complex math going on, for sure we want to test different edge cases, data integrity issues, error handling for bad input. Can you guys think of other cases that you would want to test?
Is it possible to test like when like dependencies should be updated or anything like that? Like if we're having a software that's stored over like a long period of time, maybe, or no?
Yeah, I haven't tested, I haven't wrote any tests for that, but I think that your test would fail, right? Like, your other test would fail, but I'm sure there's a way to do it. I just don't know off the top of my head, but yeah, I think that's one thing your tests are trying to catch. Yeah?
Yeah.
So the tests wouldn't necessarily be aware of the fact that there's an updated version. They could potentially check if there's a bug that you find with them. But I will say there are external scripts that will look at like your dependencies list if you have an explicit dependency list in the repo, and they'll be able to say, hey, this one is out of date, this one has a bug, this sort of thing. Yeah, there are those external scripts that'll be able to do that.
Yeah.
Really, anything there, like you want to test for a lot of different things, right? So there's nothing that I would say like you would think of and be like, oh yeah, we don't want to test for that. Adding a test for whatever you think of is usually a good idea. And like I said, this is a way to guarantee or to try to guarantee that your code stays functioning the way that you intended it to, even if people are changing other things within the code base. So your code is only as good as your unit test. So, and this is kind of the scenario we were talking about at the beginning, where the worst case scenario is that you think your code is working when it's not working and there's no error popping up. So that's when you can end up, having your whole paper written and your data analyzed, and then you realize like someone else looks at it and is like, oh, this wasn't supposed to be negative or something. And then you have to go back and redo all of that, and you've had all these conclusions with your data. So, I mean, I'm sure someone has heard of times that has happened for people. So anytime that you're kind of in the middle of development or someone else is using your code and they find a bug, that's always a great time to add another test. So if there was a bug found that you didn't know about, you fixed it, a similar bug could happen. So you want to like protect for that bug or that edge case of wherever that was found.
Converting a bug into a test is also a good way of helping to fix the bug. Because as you fix your code, you need to run tests to make sure you fixed it. And if you put that in the testing framework, it's much easier to check the test if it's just in the automatic test framework.
Exactly. So for the lab, you're going to have, there's a PyRosetta lab and a C++ lab. Actually, I guess it's just a Python lab. It has nothing to do with PyRosetta. But the ideas are going to be the same. So you're going to be given this Q class, where essentially there's a list of elements, and it's kind of the first element in is the first element out. So it's like a line. People waiting in line. You guys would be upset if the last person got chosen, the DMV. Ask me about it. I have a fun story. You have different operations that are in your queue. So enqueue adds an object to the back. dequeue removes an object from the front. You'll want to know like how many elements are in the queue, or is the queue empty? So these will all be a part of that queue class. So within your lab, there will be code that's also included. So files in the lab directory that have this class that is already written. So you shouldn't have to change that class. But you're going to write test to test that is working properly. Yeah, does that make sense? So if you're writing in C++, then that's going to be with the cxs test, and if you're doing that in Python, then that's going to be with pytest. Any questions? All right.